Okay, so take a minute, read number 23, come up with your answer. Okay, raise your hand if you think it's 1. Raise your hand if you think it's 2. Raise your hand if you think it's 3. Raise your hand if you think it's 4. Oh, we need some more time. Because no, all right, take more time. We're looking for the percent change of this function. Read that function carefully to the nearest percent. Option 4 is 60%. I'll zoom out a little bit so you can see that.
That's 2.
Shh, I don't know. We're going to all take a vote. Okay, hold up 1, 2, 3, or 4. Turn it toward me, Scott. I can't see. Oh, we got mostly 3s. And a couple 2s. I'm just rewriting this on the equation on my sheet of paper. This one is, I have to be honest, we can't tell the percent change just by looking at this. We need some work because the base is being raised to more than just an x. It's being raised to a negative x. So we need to do this first. We need to raise that base to the negative first power. This 2 kind of means nothing. But 1 minus 0.3 to the negative first power, we'll let this focus. Oh boy. Wait for, there we go. 1 minus 0.3 to the negative first power leaves me with 1.43, if I'm rounding to the nearest hundredth. So 2 times 1.43 raised to the x power. So this is something that is growing by what percentage? 43%, right? Again, we just kind of left off on this concept. 1 plus 0.43. So we're increasing at a rate of 43%. So that would be option 2. Those of you who said 70%, maybe you missed the negative in the exponent. But let's say even if it was, even if the negative exponent wasn't there, this would still be decreasing by 30%. So it's maintaining 70% of the value, but that means it's losing 30%. And the way they've kind of phrased that, what is the percent change? The percent change would have been 30% had that negative not been there. Okay, so based on the way they word it, know whether or not you should go with the 30 or the 70 in that case. Does that make sense? Okay? If they're asking you for the change, they're asking you for the R number. If they were asking you what percentage is maintained, then they're asking you for the simplified version. Okay? So 2 little hang-ups there. But did we miss the negative sign? Raise your hand if you didn't see that negative sign.
I just didn't know you had to put it in
Okay. Well, it was kind of also like the first question that we just went over, well, it was that 4 to the negative 2x that we just went over on our little quiz. You can't look at this and tell me that that's growth until the x is the only thing in your exponent. So we did that first. We got 0.11 or something like that, and now it's clearly decay. By what rate is it decaying? And that's where the 89% came in. Okay? All right, number 24. Put that on your paper, and I will show you number 24. All right, it's kind of a lengthy piece. Take a minute to read that. Okay, we have 3 rates of changes to calculate. From negative 2 to 4, so that would be from here, negative 2, 0, to 4, negative 8. We would do a slope formula for those 2 points. On our second graph, they're giving us the actual equation. When x is negative 2 on this absolute value graph, what's the y-coordinate that goes along with that? 2 times negative 2 is negative 4. Negative 4 plus 3 is negative 1. The absolute value of negative 1 is 1. 1 plus 7 is 8. And the x-coordinate of 4, because we're going from negative 2 to 4, would be 11. 11 plus 7 is 18. So we'll do an average rate of change slope formula for that. And then on the last one, they're giving you a graph. So you can grab your point from the graph. We've got negative 2, negative 12, up until 4, 0. And you're calculating all 3 slopes and then comparing them. Okay? Your homework for tonight is on